In our universe, everything is supposed to follow rules. But somewhere in space, a black hole exists that should not exist at all. And its discovery is forcing scientists to rethink the laws of physics. For most of the 20th century, black holes were considered mathematical curiosities, strange solutions hidden inside Einstein's equations. Even Albert Einstein himself doubted that nature would ever allow such extreme objects to form. According to general relativity, a black hole is created when matter collapses so completely that space and time fold inward, forming a region where gravity becomes infinite. Nothing escapes, not even light. For decades, this idea remained theoretical. Then, slowly, evidence began to appear. Astronomers observed stars orbiting invisible masses. They detected powerful X-ray emissions from empty regions of space. And eventually, they recorded the ripples of space-time itself, gravitational waves produced when black holes collided. By the early 21st century, black holes were no longer hypothetical, they were real. But as our ability to observe the universe improved, something unexpected happened. The universe stopped behaving the way we predicted. According to modern astrophysics, most black holes form when massive stars die. A star spends millions of years balancing two forces, gravity pulling inward and nuclear fusion pushing outward. When the fuel runs out, gravity wins. If the star is massive enough, its core collapses, triggering a supernova explosion. What remains behind depends on mass. Smaller remnants become white dwarfs. Heavier ones become neutron stars, and only the most massive cores collapse into black holes. But there is a limit. Physics predicts that stars within a certain mass range should never form black holes. Instead, they should explode completely, leaving nothing behind. This forbidden zone is known as the black hole mass gap. For decades, it was considered one of the most reliable predictions in stellar physics, until it wasn't. In 2019, astronomers studying a star system in the Milky Way made a disturbing discovery. The system, known as LB1, appeared ordinary at first, a bright blue star orbiting something invisible. But when scientists analyzed the motion of the visible star, they noticed something strange. It was moving too fast. The only explanation was that it was orbiting an object with enormous mass, an object exerting a gravitational pull far stronger than expected. Calculations suggested the invisible companion was a black hole, but not just any black hole. Its estimated mass placed it directly inside the forbidden zone. According to existing models, it should not have been able to form at all. At first, skepticism spread quickly through the scientific community. Extraordinary claims require extraordinary evidence. Researchers questioned the measurements. Some suggested the system might contain multiple stars instead of a black hole. Others proposed errors in distance or brightness estimates. But as additional observations were made, the core mystery remained. Even revised measurements still placed the object dangerously close to theoretical limits. The mass gap was no longer empty. This discovery was deeply unsettling, not because it was dramatic, but because it was subtle. The universe had quietly violated one of its own rules. And this wasn't an isolated case. Around the same time, gravitational observatories such as LIGO and Virgo were detecting black hole mergers across the universe. These signals told a similar story. Black holes were colliding with masses larger than expected. Some appeared to have formed too early in cosmic history. Others seemed to exist in environments where black hole formation should be impossible. One after another, the data began to suggest a disturbing possibility. Our understanding of how black holes form might be incomplete. One explanation proposes that some black holes are not first-generation objects. Instead, they may be the result of previous black hole mergers. When two black holes collide, they form a larger one, a second-generation black hole that can exceed traditional mass limits. Another possibility involves the earliest stars in the universe. The first generation of stars, known as population 3 stars, may have been far more massive than stars today. Formed from pure hydrogen and helium, they could collapse in ways modern stars cannot. But there is even a radical idea. Some physicists believe that certain black holes may not have formed from stars at all. Instead, they may be primordial black holes, objects created directly from density fluctuations in the first moments after the Big Bang. If these black holes exist, they could explain why some black holes appear where no stars ever lived. They could also help explain dark matter, one of the greatest mysteries in cosmology. But black holes challenge physics in ways that go far beyond their origin. They also challenge our understanding of reality itself. According to general relativity, anything that crosses the event horizon of a black hole is lost forever. Information is destroyed. But quantum mechanics says that information can never be destroyed. Both theories are extremely successful. Both are verified experimentally, and yet inside a black hole they contradict each other. This contradiction is known as the black hole information paradox. For decades, it has resisted every attempt at resolution. Some physicists believe information is encoded on the event horizon itself. Others suggest it escapes slowly through Hawking radiation. And some propose that space-time inside a black hole behaves in ways we do not yet understand. What makes impossible black holes so important is that they push these problems from theory into observation. They are not abstract equations. They are real objects, shaping galaxies, warping space-time, and quietly exposing the limits of human knowledge. The black hole in the mass gap doesn't announce itself. It doesn't emit light. It doesn't explode. It simply exists. And as long as it does, it reminds us of a humbling truth. The universe still holds secrets powerful enough to change everything we think we know. If you want more real stories from deep space, subscribe to the channel. And tell me in the comments, do black holes obey the laws of physics or reveal their limits?